In lesson 25, we're talking about rational expressions, and really the hardest part is students get confused with rational equations. When do you do it the equation way? When do you do it the expression way? What's really going on with that? So, beginning with this definition, a rational expression is something that's written like a ratio, like a fraction, or a sum or difference of those things. So I could have a over b and just that. I could have ax squared over 4y, or I could add them together. Or I could have that last one where I've got something squared over something, and maybe I subtract that from everything that's in there. But I don't have not all of that equals something else. I don't have two things with an equal sign between them to start with. I only have one side or one side equals, but they don't tell me a second side. I cannot solve it. All I can do is either subtract them and get an answer of what it equals. I can simplify it as much as possible, but I can't solve and say, A is this number, X is that number. If it is an equation, if I do have both sides on it, so if I have something plus or minus something else equals a third thing, then I clear the fractions and I multiply both sides by the least common denominator. But what we're doing today is only expressions. And expressions, I only have something plus or minus something. I don't have the equals on the other side. In that case, I've got to change each one so it has a common denominator, and my final answer will be something or other over that common denominator. So, if it's both sides, you can multiply by the LCD and get rid of the denominators. If it's just one side, you're stuck with keeping the denominators all the way through. So when they give you something like this, you cannot multiply by x times x plus a. Instead, you must get x times x plus a as each of the denominators. So, for this first one, I need to get it. So it is x times x plus a. And I need to get the second one. So it is x times x plus a. That means I need to multiply numerator and denominator by the same thing. If I multiply this by x plus a in the denominator, I must multiply the numerator by x plus a, and even if you multiply it, I count off if you only write it once. You need to write down that you're multiplying both of them. So this numerator becomes our 4 times the x plus a. This one over here, we have the x plus a, and we're multiplying both of those by 6, so we have the 6x. Then when we add them together, we have x times x plus a for the single denominator, distribute, and we have 4x plus 4a plus 6x. Do I have any like terms that I can combine? I can combine the x's, so I can say that that is 10x plus 4a over x times x plus a. I need to think about, can I simplify that? And what I'm looking for is if there's going to be anything that I can cancel numerator and denominator. Is there any way I can factor that numerator? What's the GCF of the numerator? So I could pull that out. Does that give me anything that matches in the denominator? No, so there isn't anything that I can cancel. So I could do either of those last two, but this one is better because it shows I've thought about how do I write it out to check if there's something that can be canceled and simplified. Now, when I am doing these, I generally don't write out this step. I simply write it the way you had it up here. See, it really ended up looking like the very same thing. So I don't write it twice. I just write it the way that I did on the first one. Must end up with one single denominator. That's that common denominator, Thomas.
You did the first one in the beginning. Do we have to write the numbers in bold, or can we just do the second step that you did?
Well, let's do this one the way that I'm more talking about on the next example. I think that'll make it a little bit clearer. So, you have one like this that you see in the book. What I would do is I would copy it down with some extra space between the terms. I'd leave a little, so I've kind of got some space here where I can write what I multiply numerator and denominator by. I'd leave a little more space here to make it easier to show what I'm multiplying the 5 numerator and that invisible denominator by, and then space on the other one. Then I would say, oh, I need to end up with a common denominator that is m squared times m plus 4 times the 1 that's under the 5, so I don't need to write that one down. Okay, this denominator is m plus 4. It is missing the m squared. It's not okay to just multiply the denominator, so I have to write that twice, that I am multiplying the numerator so that it looks like that, and I put the parentheses in there, because I'm multiplying that whole numerator and whole denominator by the m squared. Now 5 is missing everything, so I have to multiply that numerator by m squared times m plus 4. See what I mean about I should have left some extra room in there. And if I multiply that numerator, I have to multiply this invisible 1 in the denominator by m squared times m plus 4. And then for this one, it has the m squared, but I need to multiply that denominator by m plus 4 if I'm going to have the common denominator. And it's not okay to just show the denominator. We have to show that we're multiplying the numerator. Now we have a bunch of distributing to do. So Austin, what do I get when I distribute this first numerator? Everybody get there? Now this next one, I have 3 things. I have 5 times m squared times the m plus 4. 2 of them are just single things. So I'm going to say, oh, I really need to multiply 5m squared times each of these, so that I get plus 5m cubed plus 5m squared times 4 is 20m squared. And then this last one's easy, plus 2m plus 8. Now we're looking for like terms. And what are some of the like terms that we see in there? Offhand, do you see any like terms we can put together? None of those can be added?
Oh, sorry. 20 plus 3m squared and then m cubed.
Slow down, just do one of them. 20m squared plus what?
3.
And what will that give us?
23.
So that much is a 23m squared. Bella, are there any other like terms? And what does that give us? Can I put the 2m or the 8 together? So we just keep those. And then we've got to keep it over our common denominator. And is there anything I can factor out of that numerator? Is there any GCF or anything? So I'm done. So does that answer the question of showing the work?
Yes, I was just wondering if, so you know what we need to multiply at the top next to the numbers?
Uh-huh.
Do we need to do that?
Yes, or you're going to make mistakes. Trust me, you're going to have mistakes in there if you try to do it in mental math.
If we still didn't write it like the other step we were doing then? Or
I'm not tracking with you because what I ended up doing when I copied it down, I still ended up with this line. I just now didn't end up with it twice. If you start with it with some space in it, and then show what you need to multiply numerator and denominator by for each piece of it, then do that distributing or whatever is involved with it, and then combine your like terms. Okay, let's do one more, and then I'll hand out those whiteboards for you guys to do some. Okay, this one's a little bit tricky. The second denominator is nice, but can we factor that first denominator? So this is what you talked about yesterday. If it starts with x squared, but in this case z squared, the only way we get that is if we have z times z. And now I need two numbers that multiply to be positive 4 and add to be positive 5. Who can think of them?
Four, that's 4 times 1.
So plus 4 and plus 1 multiply to be 4 and add to be 5. And it's kind of nice because we've already got one of those. So that tells me that my least common denominator needs to have a z plus 4 and a z plus 1. Already got the z plus 4, and I also need a z. So when I'm copying it down from the book, I do the z plus 3 over, and I wouldn't write that at all. I just write the z plus 4 and z plus 1 under that first piece. And then I'd copy the second part, and then I'd say, oh, but if this is going to be my common denominator, this one is missing a z. And if I multiply that denominator by z, I need to multiply this whole numerator by z, so get the parentheses on there. I have to multiply the whole numerator, not just part of it. This one has the z and the z plus 4, but it's missing the z plus 1, so I need to multiply numerator and denominator there by z plus 1. So Austin, what do I get when I distribute on this first one? Now, here's where we need to be careful. There is a minus sign in between here. So I am going to think of that as a plus -1 times this one. I don't have to do as many steps. Then if I take the -1 times the z, I have minus z, and the -1 times the 1, I have a -1. Then we put our z's together, so we have z squared plus 2z minus 1 over z, z plus 4, and z plus 1. And then we need to look at that numerator. Can we factor it? Are there two numbers that multiply to be -1 and add to be +2? Anything I can think of to multiply and get -1 is plus and minus 1. And those don't add to be +2, so we can't factor the numerator, so we are finished. Questions from anybody?